Okay. So what is a deep neural network and what is a handwritten character? Handwritten character, that is the natural characters that we have written using our hands. So the handwritten character recognition is one important problem of a document analysis and recognition. So as per the literature, it is witnessed there are various work that is already done, but majority of this work exists for Latin language, for Chinese language, for Arabic language. But dear participants, there are many less work is there in the Hindi handwritten. So this work, it is basically studying the different existing work, and it has developed the new techniques to enhance the accuracy of the Hindi handwritten character. So the first effort made to develop the feature extraction algorithm. So what is a feature extraction? Feature extraction, that means the small features are there for the handwritten that we need to recognize it. So using deep neural network further, it is proposed with the PC algorithm with the feature extraction process. So in the today's scenario, the demands technique, which is a fast along with the high recognition rate and computational efficient. So here, there are many classifications error and similar character which are quite challenging and discriminate. So these work is specially deal with the recognitions of the handwritten Hindi scripts, and the scripts have the minor differences that can be sensed by the human beings. So the primary goal, just to wait. So the primary goal of this work is to identify the region called the critical region, which has minor differences. So the primary goal of this work is to identify the region called as a critical region and which has the minor differences, and it is get the additional features for the classification. It is also quite too challenging to identify the critical region in the character. It is written by the different writers. So for this purpose, the Fisher linear discriminant function, it is used to identify the essential critical region to figure out the additional features from there. So the OCR, that is the optical character recognition. The optical character recognition, it is already available online for the Hindi, for the English language. And it is very too easily recognized from the image. But it is a widespread technology to recognize the text inside the image. If I have the image, I want to recognize it. It is very easy using the OCR. So OCR technology is used to convert the virtually any kind of images that containing the written text into the machine readable text data. Either that written text into the typed format, either the written text into the printed format, or either it is there in the handwritten format. So this is called as the OCR technology. And the OCR technology that became a popular in early 1990s while adapting the historic newspapers. Since then, the technology has underwent several improvements. The most well-known use case for OCR is to convert in printed paper document into the machine readable text documents. So what is the definitions of handwritten character? The handwriting is a task of transforming a language represented in the spatial of graphical form. And the handwritten recognition is, it is a process to allowing the computer to recognize the written or printed characters, such as the number or letter, to change them into the different form of the computer. And it is in the editable format, and it is in the searching format. So how the handwritten character is recognized in the image processing? So it have some steps, it have some phases. What are the phases? First one is the optical scanning. If I have the characters, handwritten characters on the page, I want to scan it using the scanner, or I want to capture the photo using the camera. After optical scanning, the pre-processing stage is there. The pre-processing stage, that means what? It is if there are any noise are there in the background of the image, it needs to be, it removed. When I want to go for the location segment, I want to remove it using pre-processing statements. So after it, location segmentation, where the character is located. So it is described in the one particular green box format. I have the practical demonstration, dear participants. I will show you at the last. And the next one is the feature extraction. The feature extraction is nothing but each and every characters have the features. If we have the, we all are the human, right? We have the different body part. So even the body part also have the different features for the face recognition, even for the fingerprint recognition, right? So for the same, the feature extraction is also there. After it, recognition, and after it, post processing. Post processing, that means if I want to edit, it is very easy to edit. So when OCR was come in the market, there are many generations are there. So in the first generation, the OCR appeared during the 1960 and 1960 to 1965, 5 years. And it is a 10 different fonts were recognized by this OCR. Only the 10 fonts in the first generation. In the second generation, 1960s up to 1970s. And the first system of OCR was developed by IBM in the 1287. And for the Latin script. And in this period, the OCR-A and OCR-B systems was also developed. And after in the third generation, that means in the middle of 1970, due to the advancements of the IT information technology with the low cost solutions with the higher accuracy were achieved a main objective. In the present OCR, each and every language now it is very easy to recognize it, such as English, Latin, Chinese, Cyrillic, Far Eastern, and many Middle Eastern scripts. And for the Hindi script, OCR system are still in the research and development stage. So after literature review, it was identified that There are many researchers are doing the research in the Hindi script. So that's why we chosen the topic of the today's webinar is Hindi handwritten characters. So why Hindi? Why Hindi? Why the Hindi language? Because there are many languages are available. So as per the literature review, in the figure 1.2, the population of the Hindi is 41%. And see in the graph, it is the higher ratio. It is the higher ratio. The next, when I want to go for state-wise language preferences in this chart in 1.3, the Hindi in the middle, it have the more and more ratio. When I want to go for 1.4, the highest plot is there for the Hindi language. So why? Because of this reason, we chosen the Hindi language. And Hindi language is the regional language for Marathi, for Marwari, for Kashmiri, for Bihari, for Bhojpuri. In each and every language, the regional language is Hindi language. So now we need to learn about the anatomy of Hindi language. So in each and every language, there are many different vowels and numerals are available. That these all are the vowels. The numerals, that means 0, 1, 2, 3 to 9. The vowels identifier kana, matra, right? The next one is the compound character, that means the half character first one and the full character second one. See this one in the 1.10, figure 1.10, dear, beer, near. So na is a half and the year is full. The second letter length is full and the first letter is the half. So that is this type of character, it is called as the compound character. The next one is the constants. The constants, that means ka, ka, ga, ga up to ja, right? So these all are the very basic anatomy of Hindi language. Now we need to go ahead with the motivation. Why Hindi handwritten character? So in the today's society, all the peoples are entirely dependent on the computer system. As we all are. See, this is the live example that many of the peoples are attending the lectures, attending this webinar on their laptops, otherwise on their mobile phones. So all the people nowadays are working on the computer system. So it is very great need to quickly and correctly feed the enormous volume of printed and handwritten document data into the computer system. So the data which exists on the paper, now I want to print the data, feed using the keyboard device. So when the data is there on the paper, I want to write it in the computer using keyboard. It takes too much time and it takes the human efforts, also required much time. So for example, for bank check processing, for postcard processing, for income tax form processing, many examples are available. This all the task is having too much efforts. But if we will develop such a kind of system, it will be very useful to the society and it is very useful to all the business sectors. So what the problem that we have identified? First one is limited research in the skew detection and the correction of Hindi scripts, unavailability of proper segmentation algorithm, inability to separate the text from the document image accurately, requirement and use of large number of features for recognition, requirement of separate recognition engine for handwritten Hindi scripts, need of separation of Hindi handwritten documents in the Hindi script. These all are the problem that we have identified in this one particular topic. Now, what are the objective of this one particular research? The objective is, it is the limitation of existing pre-processing and feature extraction technique. When it is considered for the pre-processing and the feature extraction, it is developed the novel class of pre-processing and feature extraction techniques. To design and develop a new pre-processing feature extraction classification technique for handwritten Devangiri. Devangiri, it is the same as the Hindi characters. So finally, it is tested and the technique is used. So now we come on the topic of what are the related work? What are the authors that they already done this work? The first one in the year, one of the author, that is a Bajaj, and the feature is a statistical. They are using the classifier neural network, and this is the accuracy 89.98. The next one is the Ram Teke, the accuracy is 89. Lakshmi using PC algorithm 91%. So these all are the different authors. They have identified they have find out the accuracy using different classifier, and these all are the accuracy. One more author with the classification technique of neural network in the feature gradient with the data size of 4.506 and the accuracy is 84%. The next author, with the feature GSC classification neural network with the data size of 32.41 with the accuracy of 84.77. So when you see the one particular accuracy, see 84, 84, 87, 88, 85, 58, and 85, right? Again 58, 61, 85, and 83. But now I developed one algorithm. That algorithm is actually so now this is the actual methodology that I have prepared for this one particular system. First one is a pre-processing stage. So pre-processing stage, in the pre-processing, in this phase, the multi-gear handwritten characters image is uploaded to the system, which can be camera capture image or scanned image. Either it is an inputted image. I want to convert that colorful image into the binary image. So the pre-processing involves there are several operations over the scanned or captured image. So the further processing on the input image can be applied very easily. So basically the objective of pre-processing is to improve the quality of scanned or captured input image. Some of the pre-processing methods are grayscale, conversion of colored image, noise removal, binarization, skew, and slant detection and correction. So in the pre-processing, in the gray conversion, the RGB value, that 0.3 into R, 0.59 into R, and 0.11 into B, red, green, and blue. This method is used. In the noise removal, the removing noise is very necessary when I want to go for the image processing. The filtering, the filter, that means I want to filter that one particular image using certain different operations. So first one is a morphological operation. Morphological operation, that means it is very basic level expected channel to report the picture to override the convolution improvement with the unmistakable undertakings. So the concentrate of cutoff centers, I want morphological, that means I want to combine, I want to divide it one image into the different part. The normalization, it is a range of pixels, intensity, volume, and applications include the photographs with the poor contrast due to the glare. The binarization, that means it have the two value, either 0 and 1, right? 0 that is for the black and 1 that is for the white. The region of interest based segmentation. Segmentation, that means to identify the some characters on the paper. See here, the red tool is there. So the red box, that is a segmentation. They identified one letter, one font on the paper. The next one is a line wise recognition of interest based segmentation. Line wise, that means the straight text line having the enough horizontal white spaces between the line and segmented very easily. The next one, that is the word wise region of interest. Word, that means machine, that is one word. So it is identified the one particular segmentation using the word machine. The character segmentation, that means one character is identified in the segmentation. So here the green box is there. See on the on the slide, the screenshot is appeared. That character segmentation, that means may, that is a character statement segmentation, and header line identification, that means the Hindi language have the header line. So header line is also identified. Character segmentation, character, that means each and every character is identified the system. So segmentations of the Braj Hindi script. Yes, here I am. There are many Hindi. There are many different types of Hindi scripts are available. Right. First one is the Braj Hindi. Second one is the Haryanvi Hindi, Chhattisgarhi Hindi, Audhi Hindi. This all the Hindi language that I have identified in this one particular research work. Right. So in the line segmentation, there are 213 characters are there, 227, 225. So the accuracy is 100%. In the word segmentation, accuracy is 100%. And the character segmentation accuracy is the 97%. Now the feature extraction. So if I want to go for the feature extraction, one method is there, SVD, that is used, singular value decomposition. That similar value decompositions have the M is equal to U into sigma into V raised to T. That means U and V, that is the orthonormal, right? And E and the sigma, that is the diagonal matrix. The image, it is based on the matrix. So if I want to multiply these two value with the matrix, it is typically without any loss of the informations to achieve the output. So discrete Gaussian transformation, that means the later is the Zagra. The notate the circled portion, the discrete Gaussian transform. This is one method. That method is identifying the feature, those feature are the round. In the Jagra, see the G, that is in the round symbol. Even the Dehri la nahi, right? Again here, all the things are there in the round, right? For the same, which method is used? Discrete Gaussian transform method is used. The next one is discrete wavelet transform. This is the computerized technique to fast wavelet transform for the signals. So it is very easier to operations and implementation within the low pass filter and the high pass filter. The deep neural network. The deep neural network have the three layers: input layer, hidden layer, and output layer. In the deep neural network, that these all are the layers are recognized with the objective that they are useful for taking out the focal highlights in the feature. So 4 layers, these all the layers, it was utilized, and in each layer there are 3 basic activities are performed. The first is to use the channel partition. For all the layer, the channel part is of the size 3 by 3. The fundamental 2 layers is there for the 32 pieces and 64 join area each. And this accomplished non-linearity towards the end, and pooling is the applied with the decreased size of the section maps. So with the fully connected layer, the data center is 54 divided by 69, and distinguished center of points is the 100 of each. Right? And yield nodes, that is the 38. This all the layers are connected with the nodes in the deep neural network, right? So the performer work is the mean square error. So when I want to go for the different layers, so in the hidden layer, again, there are 100 and 600, the W and B, and it is it is raised to I, and in the hidden layer it is raised to 2. In the output layer it is raised to 3. So it is in the increased format. So when I want to go for the increased format, the deep neural network that train the data set that we have identified for the handwritten character recognition. The next one is the feed forward back propagation deep neural network. In the feed forward back propagation deep neural network, it is the also one AI concept, and in this there are many different form of recurrent neural networks are available. So these feed forward neural networks, the first angularly simplest type of AI with the neural network is devised. So in this one particular network, the informations move only in one directions, and in only in one direction with the forward and the backward format, and the input node through the hidden nodes and the output nodes. So it is go on the feed forward. That means input to output nodes. So I have collected the samples of data over here. In the year 2017, in the Hindi language, the total data size is 546, and data set type, just 1 minute. Dear participant, just to wait for a while. So in the year 2017, there are the Hindi language, and with the data size of 546 and the isolated numerals, the number of writers with the number of writers are the 0, the age is also 0, and the gender, I also identified the data based on the gender, male and the female. In the year 2018, the data set size is 348, and with the strings of online and the offline numerals, with the isolated numerals, but all the number of writers and age and the genders are the not applicable. It is 0. But when I want to go for my research work, and in the year 2021, I have identified there are total 830. Yeah, okay, thank you. So we have discussed the simple data analysis, right? So based on that, in the year 2021, there are Hindi scripts with Haryanvi, Chhattisgarhi, Audhi. These, based on that, all the scripts I have identified, there are total 830 data. And this is, there are not only the character, there are not only the word and the paragraph, it is the combinations of the character, words and paragraph. And the total is, and the total is 489 with the group of people, and out of that 200 male and 289 females. So based on that, this is the one sample of Braj Hindi written by the male and the age is 24. This is the Haryanvi Hindi written by one of the female and the age is 20. This is the sample of Chhattisgarhi Hindi written by female and the age is 35. This is the sample of Audhi Hindi written by the one of the male, age is 68. So after sample data analysis, the Devanagari basic characters that contain 12 vowels with the 36 constants. According to the vowels and the constants, the rod characters, words, and the statements, there are 4 the different scripts. And we were collected, there are 489 writers to resulting in the database. After the isolated manually and stored in the separate database in the folder created according to the gender and the age of people. Samples were collected from 489. And we have almost 6 months to collect the samples of data sheets from 489 persons, and to create the database, it consumed 1 month and more. So in the handwritten Hindi character, the pre-processing, segmentation, feature extraction, classification, and the post-processing techniques are there. With this noise removal modifier median filter that I have used, in that the set A max and the metric size is divided by 2. So both the mean and the max size, if it is more than the median, the median filter, it is used for the modification. With the binarization, in the binarization again, it have the two value. Either it's a 0 and 1. The 0 is for black and the 1 is for white. The next one is the normalization. In the normalization is mean value. It is identify the weight and the height of that one particular image, that is called as a W1 and H1. Again, with this, I want to divide it, that value, with the max of, it is width of the character, and the H1 that denoted the height of the characters. The segmentation using the practical swarm optimization. It is the one alternative value at best level which is tracked by the PSO. PSO, that means the practical swarm optimization. This is the one method. That method is used to present the neighborhoods of the neighborhood pixels in the image, such as the current velocities, even the current positions of the one particular character. Even the distance between the current positions and the other one particular pixels, G best and P best. Okay, so this is the one method. That method is used to identify the neighborhood pixels. The BAT algorithm that is also used. The BAT algorithm, it is the one method. That method is used for the filtering, noise filtering. With this algorithm, it is mainly used to segment the line, word, and the character of the written text document. And with this kind of population, the fitness of the functions of BAT is described as the follow. The J, that means dimensions, can be represented using the J, right? So it is denoted by the ith and teeth movement. Okay, so with that, it is denoted with the loudness. With the feature extraction, the directional distance distribution, that one algorithm it is also used. It have the two variations have been proposed for case when it is desired black or white pixels is not found on reaching to array boundary. Either the array is assumed a circular in a search continuous reflected directions, and in that the later one is experimented with the work and search halls. It is reflected by 5 by 5 zones. In the 16 DDD value, DDD, that means directional distance distribution, the 16 value, it is computed with the pixels and the average of DDD value. The next one is the hue movement. Hue movement, that is also done with the different shapes of the one particular character. The Zranic movement, it is the complete orthogonal set over the unit disk. This is the Zring movement. See, in this one particular image, it is mentioned that those value is the one. It is the one white. The white, the one, it is denoted as a white, and the background, that is black. Right? So those values are one. It is displayed as a curve. So those characters are there in that one particular pixels. That pixels value is 1. The Gabor filter. The Gabor filter have been used extensively in the image processing and texture analysis for their excellent properties, frequency, and orientation representation. So where here the equation is hxy is equal to jxsy into sxsy. So sxsy is a complex sinusoid known as a caret, and g is the Gaussian shaped functions known as the envelope. The Gabor filter is a multi-resolution Gabor features, complex sinusoidal, Gaussian developed, and the Gabor filter. The deep neural network classifier, it is called as the learning approach. where it could be used for human to obtain the knowledge. In the another word, it will be considered as a new approach to automations of providing or predict predictive based analysis. The deep neural network is shortly known as a DNN, an artificial neural network with the various hidden layers. The hidden layer, there are three layers: input layer, process layer, and the output layer. So these layers are placed between the output and input layer, and it is used to develop the complex relation in the linear. D1, the DI is the differing functions related to the original image, where it is called as the mean squared error. The algorithm's deep neural network classifier, the training set it have the target, feature, hidden new variables, iteration max, weight, and the bias. So with this, the output is a network. Start the network initialization 1 and for if it is train set cat 150 and it is a target is j is equal to j. If both are matched, then it is and it is train the set with the plus plus. So after this all the algorithm, the result that I have analyzed it, sample data representations with labeling. There are total parameters is 632, 589, and 523. The parameters set up for the deep neural network using support vector machine, that is a 654, 764, and 538. The parameters set up for the multi-layer perception is 389, 782, and 386. For the hidden Markov model, 746, 689, and 745. With recurrent deep neural network, the total parameter is 389, 782, and 386. For the backpropagation neural network, the parameters are total 467, 562, and 486. After it, total recognition rate of Hindi handwritten character is 100%, except the writer 4, W1, W2, that means the writer. The next one is the Haryanvi Hindi. Again, it is the 100, 90, 96, 96, 90, and total is the 94. The analysis of the Hindi is total is 82.67%. The analysis of Chhattisgarhi Hindi is 84.67% accuracy. So after this, all the recognition, the conclusion, if I'm using the deep neural network to identify the character recognition for the organizations of designing the RMS prop method with the NA6. So it is a profound learning with the noticeable and advances that have been tentatively concentrated with the whole significant regions of PC vision and archive examination. So in this one particular research, tentatively built up a profound convocational neural organization and the versatile slop, that is a strategies with the Devangiri characters and the profound convocational neural organization that helped to identify the best accuracy for each and every characters. So most noteworthy acknowledgement precision is 96.02, utilizations of NA6 organization with the RMS prop and with the DCNN algorithm with the NA6 with the layer-wise preparing model, total accuracy is acquired 98%. That is the highest comparatively previous all 7 years accuracy of Hindi OCR. So, which is the most noteworthy acknowledgement precisions of the data set. Now, in the future, I will be added the time of processing, and combine proposed algorithm with the one hardware. Now, here I have the practical demonstration. These all are my publication, dear participants. These all are the paper presentation in the different conferences. Even I also have received the very best research paper award 2 times. First one, it is organized by one of the in the conference organized by Nirma University, Ahmedabad. And the second paper that I presented, Best Research Paper Award in the National Institute of Engineering and Research, Government of India. Even I also published this book chapter that is related to this research. Even I also received the 1 lakh rupees grant of from the GISC SSIP Government of Gujarat. Even I also patented this algorithm with the Government of India. And these all are the references that I have kept it in the PPT.